Back at the beginning here, or back in the last example, we had the identities, Pythagorean identities that you're going to be using to verify identities. And what you're going to be doing is you're basically just going to be simplifying one side of your equation to make it look like the other side. Usually the best thing to do is to start with your the ugly side. Start with the ugly side and simplify that. Okay? So what we're going to do is we're going to try to simplify this here on the right. Well, if you notice, on the right side you have this fraction, and you have two terms. So if we're trying to get this simplified down into one term on the left, then what we're going to need to do is we're going to need to do something here on the right where we can add these fractions together. So and a lot of these problems just take a lot of trial and error as you do these. So just try to simplify. Use different rules of simplifying, like adding fractions with different denominators. You have to rationalize some of your denominators. You have to use substitution and all kinds of fun things. So I know you guys will really enjoy these because in the past 3 years, everybody's loved these the most.
We hate this, Mr. Clark!
Oh, sorry. Well, maybe you won't like this the most, but we'll try it anyway. So if you want to add these together on the right, you're going to need to have a common denominator. So you're going to need to multiply top and bottom by a sine squared theta. And that's going to give you a 1 minus sine squared theta all over sine squared theta. And it's going to be handy and helpful to have your trig identities near you when you're doing these, because if you look at the 1 minus sine squared theta, and if you look back at your trig identities, back here, which ones include a sine? Well, there's 3 of them, and the top one is the only one that includes a sine. So if you look at the sine squared theta plus cosine squared theta equals 1, if you were to subtract sine squared theta to both sides, I'll show you that over here. If you were to take, oops, sorry. If you were to take sine squared theta plus cosine squared theta equals 1, is there something you can do with this equation to make it look like this one? What? What's that you say? Oh, thanks, Kim. You need to subtract sine squared theta both sides. And when you do that, you get a cosine squared theta is equal to a 1 minus sine squared theta. So what you're going to be able to do is you're going to be able to take out this 1 minus sine squared theta and substitute cosine squared theta. So let's show that down here on this next step. So you have a sine squared theta, and we're going to plug in a cosine squared theta on top. And if you recognize here we have a fraction, and we're trying to get it equal to our cotangent squared theta on the left. Well, if you look back at your identities again, cotangent is equal to a cosine over a sine. So even though those are squared, we can make this a cosine squared theta, or sorry, cotangent squared theta, cosine squared theta, and a sine squared theta. And you're going to be able to use substitution once again, and you're going to be able to show that cosine squared theta is equal to a, sorry, gosh dang it, I can't talk. Cotangent squared theta equals cotangent squared theta. And so what you've done there is you have proved that the right side and the left side are equal to each other. So, there's your check mark for doing such a great job.